Hello everyone, myself Manasa Musnuri. Today we are gonna discuss fraud detection using information retrieval. Fake news is a huge issue these days and we need smarter way to detect it. In this project, I'm using machine learning to figure out whether a news article is real or fake. Initially, here in the script, I'm importing all the necessary libraries for data processing, pandas, nifty, for machine learning, sklearn, and for visualizations, matplots. Count vectorizers and TF-IDF vectorizers are used to text feature extractions. And also here we are using various classification models like SGD classifier, logistic regression, random forest classifier, multinomina NB, and linear SVC import also were being imported. Firstly, the dataset is read from CSV file into a pandas data frame. This dataset likely contains text-based data for fake or real news classification. And then here we are checking the shape. This line represents the number of rows and columns in the dataset. Next, we are checking for the size. This returns the total number of elements in the dataset. DF head displays the first 5 rows of the dataset to understand the structure of the data. Next, here we can see the setting the index. The dataset contains an unnamed column that is likely the index from the CSV file. This line sets the column as the data frame index. Once that is done, again we are seeing the first 5 rows over here. And then next we can see y is equal to df label. Here the label represents the column which contains the real and fake classification targets. And thus we are assigning to y as an independent variable for training. Next, we are splitting the data into training and testing sets. The test column contains the actual new contest which serves as an input x. The data set is splitting into training and testing. The training is 67% and the testing is 33% using the train test split. Next we can see count vectorizer, count train and count test. So count vectorizer converts text into a matrix of token count, ignoring common English stop words. And we can see here we have fit transformer, learning the vocabulary and transforming training test into a spare matrix. Transforming X text. Transforming test data into the learned vocabulary was being done over here. Here, next, we are displaying the first 50 words or the features extracted by the count vectorizer. And print length count, here this prints the number of unique features in the vocabulary. The same thing which we have done for the count vectorizer was being repeated for TF-IDF vectorizer. Even here we can see TF-IDF vectorizer assigns important to the words using term frequency inverse document frequency, which is TF-IDF. And here we can see max DF 0.7. This ignores the words that appears in more than 70% of documents. And similarly, fit transform extend learns and applies TF-IDF transformation to the training data, and transform X text applies the same transformation to the test data. Checking frequency extracted TF-IDF features. Here again, this displays the first 10 words or the features extracted by TF-IDF vectors. Once the length of TF-IDF vector is done and also the convert vectorization is done, here we are counting the count train matrix created using count vector is converted into a pandas data frame. Each column represents a unique word and each row correspondent to a word to a document with a word count. That we can see here the print length of count train A and print length count text A. And once that is done, here we are again defining the shape of count df, and again we are checking the size of the count again. So here this shows the how many documents were being processed for the test and training. And it also tells us the number of rows and columns, and size tells us the total number of values. Once that is done, we are displaying the first 10 rows of count vectorized data. And this shows the word frequency count for the first 10 documents over here. The similar thing, whatever that we are looking in count, the same thing was been done for TF-IDF vector also. So the count DF, this creates a data frame for TF-IDF values where each column is a word and each row is a document. And then here this helps to verify the structures and the shape of the TF-IDF matrix, the DF shape and the DF size. And then here we can see the top 10 TF-IDF scores. And now we are finding the difference between the number of features between the count vectors and TF-IDF. And with this we got a printout which tells us there is no difference between the count vectorization and TF-IDF vectorization. Now let's define a function to plot a confusion matrix. So here this function visualizes the confusion matrix which helps understanding how well the model is performing. A confusion matrix shows true positive, correct fake classification, true negative, correct real classifications, false positive, fake misclassification as real, and false negative, real misclassified as fake. And now here we are doing the training and evaluation for Nivea Bytes model, multinomial NB. Here we can see we have initially started seeing this for TF-IDF model. We train a multinomial Navier's classification on TF-IDF features first. We predict the labels for test data and classifying the accuracy over here. Here, the confusion matrix help analyzing the model performance. The accuracy of TF-IDF using multinomial NB is 85.65%, and we can see the confusion matrix without the normalization here. The same thing was been applied for the logistic regression, and the accuracy of logistic regression is 91.3%. And here we can see the confusion matrix without the normalization again. Next comes the linear SVC. For this linear SVC model, the accuracy is 93.63%, and here we can see the confusion matrix without the normalization. Next comes the SGD classification. So for this SGD classification, we can see the accuracy as 85.65% and the confusion matrix without the normalization. And the same thing was been done for the random forest classifier also, and the accuracy for this we can see is 90.1%. And here we also can see the confusion matrix without the normalization. Same way, whatever that we have done, the training and evaluation models for the transform like TF IDF vectors, the same thing we are gonna do for the count vectors also. And here we are starting with the multinomial NB. Here we can see the accuracy for this model is 89.3%. And this is followed by the confusion matrix without the normalization. The same thing, whatever the classifications that we have applied and looked in TF-IDF, the same thing we are gonna look in for here also. And next comes the logistic regression. And for the logistic regression, we can see the accuracy as 91.1%, and here followed by the confusion matrix without the normalization. And next comes the linear SVC. And the accuracy of this model is 87.9%, and this is also followed by the confusion matrix without the normalization. And this is the output for the SDG classifier. And the accuracy for this model is 85.65, and the confusion matrix without the normalization is shown here. And lastly, we can see for the random forest classifier. And for this random classifier, we can see the accuracy as 89.8% and the confusion matrix without normalization has been shown here. Once this is done for both the vectors, next we are finding the most important word for the classification. So this function finds the most information words in detecting whether news is real or fake. And from then, this helps us to identify the keywords, and here are the results of it. First, we have seen the results for TF-IDF vector, and next comes for the count vectorizer. Once again, I would like to give a brief summary on this project again. So, initially, we processed the dataset and transformed text into numerical features using count vectorizer and TF-IDF vectorizer. Then next, we built multiple machine learning models like logistic regression, SVM, SGD, and random forest to classify the fake news. And once that is done, we evaluated the model performance using the accuracy score and confusion matrix. After that, we have identified the most important words influencing the fake news detection. Thank you.